helping you with the data and AI transformation journey. And for the session today, we're going to have examples of how companies are going to be able to use the Lakehouse throughout the whole spectrum of financial services, from banking, capital markets, wealth and asset management, and insurance. But most importantly, I would like for you to walk away with one actionable insight that you can take back to your company and make it part of your journey. The two most common questions I get from financial services clients are, number one, how are other financial services institutions leveraging Databricks? And number two, what can you do to accelerate your journey on AI and transformation? How are we going to be able to answer those questions? Well, as you can see here, we have a stellar lineup of speakers from some of the most recognizable brands in the world. The format for the next 2 hours are going to be a series of 15-minute TED Talk style lightning round sessions that will give you tips on how can you accelerate this journey. To keep the flow moving with our jam-packed agenda, I'm going to be introducing every single speaker as they come on stage. But then I'll be doing it behind the scenes. I don't want to be the person that's standing between you and the happy hour. So we want to make sure that we do this timely. And just a couple of housekeeping items. The session is going to be recorded, and then it's going to be aired for the 60,000 attendees virtually. And the second thing to keep in mind is that there's not going to be a formal Q&A session. The speakers are going to be joining us at the reception right after the 2-hour session, and they're going to be able to answer all of your questions. You'll get the chance to meet a lot of our Databricks partners, as well as all of our technical experts that will be more than happy to answer questions. With that in mind, let's give a warm welcome to our first speaker, Mr. Junta Nakai. He heads financial services and sustainability practice at Databricks. His session is titled Lakehouse for Financial Services, from CTOs to CFOs. Without further ado, Junta.
Can people hear me? The point of today is, I think Marcella said it really well, is about taking the things that you hear today and putting that into action. So you'll hear a lot about the use cases, the business impact that many of our large customers and partners are getting through using Databricks and the impact that it's having. And the big action item I have from listening to the keynote this morning is apparently if you work in Spark, your salary went up 30% year on year. I don't know if you guys saw that. So I'm going to have a great conversation with my boss, who's standing back there, because technically we work in Spark as well. So very nice to have everybody. I'm going to talk a little bit about the Lakehouse for Financial Services, what it is, and I'm going to talk a little bit about why it matters now, arguably more than ever, right? So if you think about what happened during the pandemic, I would argue the pandemic accelerated greatly the adoption of cloud. And if you think about the upcoming economic volatility that we may experience, I think recession or no recession, the adoption of AI should proliferate as well, right? So if the pandemic accelerated cloud, I truly think that economic volatility is going to adopt the acceleration of AI across financial services in all the different sectors. So we already went through this. We have wonderful speakers today. TD Bank is going to be next, and Marcelo will be doing all the different introductions. So the main thing I want to talk a little bit about is about competition. So how many of you here work at a what we call incumbent financial service institution, like a bank or insurance company or things like that? Okay, so a decent amount. So this is a statistic I took a few months ago, and maybe because the market's down so much, maybe that number is a little bit different. But today there are about 17,000 financial technology startups in the world, right? 17,000. And as of a few months ago, those 17,000 produced 194 unicorns, right? So another way to think about this is that financial technology actually has the highest concentration of unicorn across any vertical, right? So this is the competition that many of you are facing today. And that competition is only being compounded by the economic hurricane, right? That's potentially going to come. So we have Arup from JP Morgan here. Jamie Dimon a few weeks ago famously said this. I don't know if you guys heard this. He said, brace for the hurricane, economic hurricane. But he said, we don't know what kind of hurricane it's going to be. Is it going to be a small hurricane? Is it going to be a big hurricane? Nobody knows. But the punchline here is that I think that cloud and data and AI are going to play a much more central role in navigating and winning in that hurricane than perhaps other times in history. And if you think about what that means from a technology perspective, I think it means three things, right? So in a period of economic volatility, you basically have to do three things, right? The first is to preserve your margins, right? Lower your TCO, right? Like everybody wants cash, everybody wants to reduce OpEx, they want to preserve cash. The second thing you have to do is find new sources of revenue. If economic growth is going to slow down, you probably need to find revenue somewhere else, right? You can't just keep doing what you were doing in the past. The third thing you have to do is you have to operate in a much more significantly shortened timeline, right? Like AI cannot no longer be aspirational. You have to deliver on that promise today, not tomorrow. And all of this actually has been captured by the CEO of Uber, Dara. He wrote a wonderful email to his company a few weeks ago, maybe a few months ago. I don't know if any of you have read it. But he touches on all three of these points. And I think he articulates it really well about the new paradigm in which companies operate in today. And the punchline here for all of us is that I'm going to talk a little bit more about Databricks and how, more specifically, the open source technologies that we leverage help companies through all three of these things. And this is why I think everything that you heard about the open source Delta, the Delta sharing, all the things that we announced this morning are going to play a much more critical role in helping companies achieve these three things in the upcoming economic hurricane that we may have. And I apologize, some of you have already seen this. But I'm a recovering banker, so I like to think about in numbers, right? So the title of this talk was From CTOs to CFOs. And because CFOs care about those three things, and I think going forward, CTOs need to care about these, right? So the single most important thing that your CEO cares about is something called return on equity, ROE, right? People have heard of ROE maybe, right? Why does your CEO care so much about ROE? It's because he or she gets paid on ROE, because ROE has a very, very high correlation with share price. The higher return on equity, the higher your stock price is going to be. And if you break down ROE, you could actually break it down into three different components of it. The first one is margins. Okay. The second one is return on assets. In other words, is productivity, is sales over total assets, how productive you are using the assets that you have. And the last one is financial leverage. How much leverage, how much money can you borrow? And if you think about what's happening in the economic environment today, well, what's happening, right? Inflation, right? We have the highest inflation print in 40 years in the United States, right? So what does that mean? Well, costs are going up. Margins probably starting to feel a little bit pressure, right? What's happening with economic growth? Well, are we in a recession? Are we not in a recession? We don't know. But certainly, it's going to become harder probably to find new sources of revenues because the GDP is not going to grow 3, 4, 5% like it has in the United States for the past few years. Financial leverage. What happened to interest rates? I just bought a home like last week, and I probably worst timing ever to buy a home, right? Because interest rates spiked. So all three of these things that are meaningful drivers to ROE are meaningful headwinds. They've turned from tailwinds to headwinds on a dime, right? And now what do you have to do if you're a CFO? What do you have to do if you're a company? You have to operate differently. And if you think about how that translates into technology, I think you need to do three things, right? Well, we probably can't help with the interest rates, unfortunately. But I think a technology platform like Databricks can certainly help preserve margins, lower your TCOs, right? Help you generate more cash, reduce CapEx, moves to OpEx, all the things that CFOs care about. The second thing is that I believe that leveraging data and AI enable you to uncover new sources of revenue. It allows you to navigate economic volatility, to find new use cases, to change your business model on a dime, come up with new products, all the different things that you need to do to navigate what Jamie Dimon calls an economic hurricane. So how do we do that? And how does this Lakehouse platform that you keep hearing about, how does it all play into this? And I'll talk a little bit. But as Ali mentioned in his keynote today, and I think Matei mentioned it as well, we now have lakehouses for each vertical, each main vertical. Lakehouse for financial services is no exception. right? And the lakehouse for financial services is really to help customers bridge the gap between the platform and the value it can deliver as quickly as possible, right? So the lakehouse is, as you know, it's simple and it's open and it's multi-cloud. But what have we done to make it more tailored to financial services, right? And this is what we've done. So we have something called the Lakehouse for Financial Services that we launched about 4 months ago, where we've taken the basics of the Lakehouse platform, and we've highly tailored it with technical assets, code, et cetera, to tailor it to financial services. So for example, right, we've built about 50 or 60 what we call solution accelerators that are now part of the Lakehouse for Financial Services that enable you to do use cases like KYC, AML, sustainability investing, got churn prevention, hyper-personalization, all the things that many of you are probably trying to do on a platform or started on that journey or maybe do already. We've started to integrate Delta Lake, which is the underlying technology, to major industry initiatives, right? Something like Legend, right? So I don't know if anyone from Goldman or Wall Street are here, but Goldman Sachs open source something called Legend, right? It's part of the Finos Foundation, and we're working to integrate Delta Lake into things like Legend. Right? We've created secure setups. So what we found is that many of our financial service customers, it takes them quite a bit of time to set up Databricks in a hardened and secure way. Right? In a highly regulated industry, security, hardening of the platform, having the right access controls are really important. So we have over 600 customers now in financial services, and we looked at all the best practices of how are big enterprises deploying Databricks at scale, right? And then we provided templates. So that instead of taking you maybe days or weeks, you could click of a button, get started on Databricks in a highly secure environment within minutes. Right? These are some of the things that we've done to make this lakehouse architecture much more relevant to financial services so that you could actually go execute on the use cases and deliver value and navigate the economic hurricane in a much more sort of better way. And the other way to visualize this financial service lakehouse is as follows, right? So we've built a lot of technical solutions, which I'll show you, which is on the right side. Almost fell off. The right side, right? So hey, all this data is in the lakehouse in any cloud. What are some of the use cases you could do? Maybe you want to do hyper-personalization. Maybe you want to do claims automation. Maybe you want to do telematics. Maybe you want to do, I don't know, KYC, ML, fraud detection, risk management, all these different things. So again, we've built about 50 or 60 solution accelerators that help you get on your journey to do those use cases. Right? And I just want to set the expectation, they are not turnkey solutions, but they are templates that you could use with the code and the data sets and notebooks to get you maybe 5 or 10 or 15% of the way there. So you could do two things. One is to see all the benefits and features and functionalities of Databricks within the context of a real use case that you care about. Right? And secondly, to get you on that journey to deliver value with that use case as quickly as possible. Right? So that's on the right side. On the left side, we spent a tremendous amount of time now starting to build other templates to help you get your data into this lakehouse in the first place, right? So if you're doing streaming data for hyper-personalization, maybe you're taking in files, right? Maybe you want to build your own pipelines using DLT. Maybe you want to use Confluent to bring in streaming data. All these different patterns that we see over and over and over across our 600 customers, we've now created solution accelerators and templates so that you could start feeding your data into the lakehouse, right? So the good news is, all this is publicly available. All right? Everything that we do here on the go-to-market team, we open source it, we put it on our website, anyone can download. Right? So the sustainability solution that we've created, for example, has been downloaded 14,000 times year to date already. And it's free for people to use, it's free for you to download so that you don't have to listen to me. You can actually start using Databricks to see if it's feasible to solve some of the major challenges that you have with the notebooks and the things that you have. So I want to touch upon those three things that I said before. Right? Which is preserve margins, find new revenues, and operate on a shorter period of time frame, right? Shorter time frame. Well, let's talk about TCOs for a second, right? So study after study, time and again, the lakehouse architecture, and you saw the benchmarks that Ali talked about today, they result in significantly lower TCOs than operating in a cloud data warehouse or on-premise. For vast majority of customers, right? There's reports that you could find on our websites. We didn't always lead with cost, and we still don't like to lead with cost, but the reality is in this economic environment, I think it's really important. And I think it's really important to know that the TCO of operating a lakehouse architecture from a technology perspective is going to be much lower, right? And also from a operational people perspective is probably going to be much lower as well. And that's kind of the high level. Well, let's think about preserving margins and tie this back into the solution accelerators that I've mentioned. Well, again, we have 50 or 60 of these, right? So if you're starting to think about, what are some of the use cases that we could do in financial services to save money, reduce instance of fraud, right? We built solution accelerators, for example, that help you combine rules-based and AI-based algorithms in combating fraud, right? Let's say you want to focus on finding new revenues. Right? Well, it turns out customer acquisition in financial services is extremely, extremely high. Right? It's much more profitable to keep a customer than to acquire a customer in financial services. Right? The customer acquisition cost of a really high-end credit card can be $1,000 per person. Right? So what if you could use the transactional data that you get to drive hyper-personalization at massive scale in real time using credit card data, for example? Right? This is a pattern that we see many of our customers coming to. We've created a solution accelerator for that. So now you could start seeing if Databricks can be used for things like that. Let's think about shortened timelines, right? Like AI can no longer be an aspiration for companies. It has to be a reality. It can't be delivered tomorrow, the day after tomorrow, 3 weeks from now. It has to be delivered today, especially in the period of time where opportunity costs are very high because interest rates are high. Right? You need to deliver on the value and the promise of data and AI as quickly as possible. So we've created all the solutions that I showed you on the left of the lakehouse that are design patterns of how to start doing things in financial services. In this particular example, about real-time insights, right? Maybe you want to do real-time fraud detection. Maybe you want to do real-time BI and visualization. These are the patterns that we've created and the templates that we've created that get you started as quickly as possible there. Right? So there's a ton of major use cases that we see in financial services. The lakehouse powers over 500 use cases now across financial services, across our 600 plus customers. These are the top 4 that we see over and over again, right? And in order, by the way, by consumption, probably risk management is probably your single biggest use case, followed by personalization, followed by cybersecurity, and now data democratization that you saw with Delta sharing. And sustainable finance, I just put that as a kind of a horizontal because it touches so many different things. Now, specifically, there's 2 things that I want you to take away. The first one is that we've created something called the Big Book of Use Cases for the Financial Service Lakehouse. So we talk to our 600 plus customers, we look at patterns, we look at usage, we look at use cases, and then we created this, it's all publicly available on the website that says, hey, what are the data sets? What's the architecture? What's the value of using Databricks for these kind of use cases? And that's publicly available. The second thing, and this QR code, I hope it works, is that we have, again, 50 plus solutions, right, that are on our website. All of them are publicly available, right? And we also have open source libraries. We created something called Tempo, which is a financial time series library that's been downloaded 300,000 times, maybe more. I don't know if Ricardo's in there. I think it was 300,000 times the last time we looked at it, right? Like pretty powerful stuff, all of it open source. So go on our website, and the best thing about this is you could mix and match, right? So I used to work at Goldman Sachs before I came to Databricks. Starbucks probably is going to know a lot more about personalization than Goldman Sachs, my guess, right? Adobe is probably going to know much more about multi-touch attribution than maybe JP Morgan would. Right? So you don't have to just look at the financial service solutions. You could look at what retail has built, what HLS has built, what media has built, and take the best of breed, right? And start mixing, matching, and using it, right? And I have 2 more slides, right? So some of you saw the Brick Builders program. So I know there's a lot of partners here. So we have a new program where our SI partners are building repeatable solutions on Databricks. Really, really powerful stuff. We launched a risk management one with Avanade. We have a hyper-personalization one for financial services coming out as well. This is going to make that activation of the lakehouse even faster. This is my last slide, I promise, right? So the punchline is, by leveraging a platform like Databricks, by focusing on open source, cloud, AI, all sorts of different stuff, you guys are the most important part of your company today, right? Technology, when I worked at Goldman, technology used to be a cost center, right? Now technology is the source of competitive advantage for financial service companies. And one thing I want to leave you with is some of the analysis that I've done, because again, I'm a recovering banker, called the Databricks 30, right? So Databricks 30 is a stock index of our top 30 customers across 6 verticals. And what we did, or what I did, was I plotted the share price of those 30 companies over time, right? And the chart, it's a little bit hard to see, is that's the alpha, meaning the Databricks 30 index vastly outperforms the S&P. Meaning companies that focus on cloud, analytics, AI, open source, all the things that Databricks is about, seems to vastly outperform its peers. And you'll see that outperformance starts to gap in March of 2020, right? Because crisis brings the future faster. Right? So all that agility, the resilience, all the things that the Lakehouse platform enables you to do likely seems to help our customers outperform their peers, right? This is one of the reasons why I think it's so important to think about the Lakehouse and Databricks in the context of what's happening in the overall economic environment, and we are providing the assets and the content and the solutions to help you on that journey, right? That 2x, I'll stop in a second, that 2x is another research I read from Morgan Stanley, which I thought was really interesting. They said those companies that focus on cloud and analytics and AI typically get a 2x earnings multiple versus their peers. So think about that for a second, right? Let's say your company is a big Fortune 500 company. You make $1 billion a year in net profits. And the sector trades at 8 times, right? Let's just say. Your company can trade at 10 times earnings, right? 2 times 1 billion is how many? It's $2 billion, right? This is the stock market telling us that a Lakehouse, the collaboration, the open source, the data and AI actually has a meaningful positive correlation with returns and business performance, right? So this is one of the things I think about when I look at Databricks and the platform and what we provide, and this is why I think it's so critically important, and also why you all here are the most important people at your company, because you have the ability to impact the future of your organization in ways that probably never happened in the history of history of economics, quite frankly. So with that, thank you so much. Super excited to have TD Bank, Paul and Upal. They're going to come up and they're going to talk to you about how they leverage Databricks and some of the journeys that they've been on. Thank you so much.
Thanks, everyone. It's really, really great to be here to spend a bit of time with you, walking you through our journey at TD Bank. My name is Paul Wellman. I'm the executive product owner of what we call our data as a service platform at TD.
My name is Upal. Same letters as Paul, but sequenced differently. I'm the AVP of Enterprise Data Platforms, and I'm a technology lead for our cloud data migration.
Really, this afternoon is really about talking about our coordinated outfits for this afternoon and how we dress seamlessly together. But in all seriousness, we're really focused this afternoon on walking you through what we call anticipating the next turn. It's got 3 areas that we want to focus on with you today. The first is about establishing the data backbone for the TD Bank Group firm. This will allow us to partner and create and power those moments that matter for our clients. Secondary, we're focused on driving a focus on talent, retaining our talent, and growing them at the company. And last but not least is getting into a position that prepares us for the future, being nimble and being able to adapt to Junta's reference around hurricanes coming. We don't know what the future is going to hold, but we need to be in a position to act and react to market changes. So to get started, let me introduce you to TD Bank. TD Bank is a multinational firm really focused on 5 different lines of business. We've got retail operations in both Canada and the US. We've also got a book of business in Canada on TD Insurance. We have a wealth set of operations and also wholesale banking. We're a team of 90,000 employees strong, 27 million roughly customers worldwide. 15 million of those customers are active digitally. And we're happy to say last year was a record year for us with 14.3 billion in earnings. We're very excited going into this year with our intention to acquire First Horizon Bank. And also earlier this year, we're very, very proud of our partnerships we announced with both Microsoft and Databricks.
We're also very excited to be hiring over 2,000 engineers. We're investing heavily in technology, and we're in fact creating a tech hub in South Florida.
So let's talk a little bit about our journey. The focus today is really what we've done, where we're at in our journey, and specifically where we're headed.
So number 1, it's all about thinking enterprise, right? So you have to have an enterprise mindset. At TD, back in 2015, we really started our big data Hadoop journey. At the time, the motivation was to do regulatory use cases such as Dodd-Frank, as well as anti-money laundering use cases. We then really expanded it out to all lines of business at the bank. And then over 2016, 17, 18, we really grew the platform, and we had a lot of third-party data integration tools working on top of Hadoop. The challenges we ran into was really platform currency. So anticipating the next turn, we decided to accelerate our transition to cloud. And this was to reduce expenses, accelerate analytics, as well as get value out of our data. Moreover, the talent in our teams, they were expecting to be on cloud. Right? It's cool to work in cloud, right? And then anticipating the next turn, we're making sure that we're staying nimble and we're able to handle whatever is next.
We looked at our enterprise strategy, our decision to move to the cloud. The next step was truly looking at how we operate. And that really comes down to adopting a platform operating model. What that means is, as a group, we've assembled and gathered all of our data assets in the entire company. We've brought together all of the people that work on those assets in both technology and the business. We've also combined and brought together all of the funding and decision rights and established an integrated platform we call Data as a Service. We've encapsulated all of that in a scaled agile delivery framework where we have product owners and we focus on delivering data products at scale. That's where we are today. The real question is what's next? We have a very, very prescriptive approach on what comes next. Given the size and scale of our data landscape, we're going to focus on data domains, managing our data by domains, establishing a roadmap for approved provisioning points that will help power both analytics, reporting, and data science. And from there, we'll have a very prescriptive roadmap on what order we will create those approved provisioning points and scale that for the enterprise. Throughout this entire journey, the focus has been on business value, both at the customer level and at the enterprise level. A focus on governed data platform. We understand from the changing regulatory conditions, regulators and the need to understand our data, manage our data from top to bottom is critical. And again, powering all of this is the focus on speed. Speed is the new currency, and time to insight and time to action is what will measure our success.
All right, so looking at our outcomes, what are our outcomes? So at TD, we truly have a large-scale data platform. One of the things we're unique in is we have one enterprise data platform. So we don't silo our data lakes. Like there's no data lake by line of business, or it's not also by geography. So there's no TD Insurance data lake, there's no TD Wealth data lake. In fact, it's just one enterprise data lake. And as I mentioned, we've started the journey about 7 years ago. So since that time, we've added a lot of data, a lot of workloads, and a lot of users. In fact, we have over 2,500 data and analytics users across the business that are leveraging our platform. We have over 500 data engineers, and they're using a platform that's over 20 petabytes in size. As we really scaled up and started working on hundreds of use cases, we realized we had to transform to cloud. Moving to cloud was not really an option. It was something we just absolutely had to do. So what did we do? We started the migration to cloud and really leveraging platform as a service with Databricks as the foundation. And we're, I think, in the second half of our journey now. In terms of scale, we've migrated over 450 sources. Over 8,000 ETL jobs are in the process of being migrated. 15,000 tables, and historical data of over 100 million files. So it's truly complex. At TD, not only do we have a big data problem, we also have complex data. And what this means is we're bringing in data feeds from different types of source systems, be it mainframe, relational, and so on. Databricks and Microsoft Azure gives us the ability to be nimble enough to handle these various types of workloads. So what are our outcomes? Number one, we're doubling down on a governed and trusted data platform. Metadata is at the center of it. For all of our data assets, we integrate with our enterprise data catalog. We have both technical metadata as well as business metadata. Secondly, we are unifying the experience. And what I mean by that is our data scientists and data engineers, they're all using the same platform, the same technology stack. And third, we're creating a modern tool stack that is setting ourselves up for the future. Again, anticipating that next turn. We're really creating the backbone for data.
So in the spirit of partnership, we thought we'd share some lessons learned. This has been a continuous journey of transformation and change. And really, we've categorized some of the key lessons that us as a company have gone through. So the first is thinking enterprise. With an organization the size of TD, the only way to see, manage, and create those moments that matter for our customers is bringing all of the data into one place and managing it centrally. Focusing on value. Everything we do is measured, approved, and signed off with a strict business case. That's both from a delivery of a data product to an analytical use case. Notion of a governed data platform, we know and we understand, and we have made the decision it is no longer a need to have, but a must have. It is critical, and both our customers and the environment are expecting it. Growing our people. Focus on talent. The war for talent continues. Establishing defined career paths for our data professionals, our data engineering professionals, and ensuring that we can attract, retain, and grow the careers of our people within the firm. Always on training and always on enablement, we found was one of the key successes in helping progress our people as soon as they enter the firm, demonstrating that they can grow their careers for the long term at TD.
We're also eliminating tunnel vision. So we're breaking free from conventional thinking and really thinking cloud first. One of the approaches we've taken is really to build out standardized frameworks, which Databricks plays a huge role in. So for example, we have built frameworks for things like ingestion, ETL, and orchestration. These give our data engineers and data scientists common ways and consistent ways to do everyday activities. And really, it's the connective tissue between our data teams. It also allows us to optimize cloud costs. So using standardized frameworks that are highly efficient allows us to keep costs down. Moreover, we have a really huge focus on financial transparency. So we've been creating usage dashboards showing how much our different services costing, so we're able to monitor that on a daily basis, weekly basis, as well as a monthly basis. And really, these best practices were instilled from the beginning of the program.
Great. So to start to wrap things up this afternoon, our vision as a company is focused on enriching the lives of our customers, our colleagues, and the communities we live in. And where Upal and I come in is with data. So starting from the right-hand side of the slide, in terms of focusing and helping our communities, every year we have a program called TD Mindpower. We volunteer and we partner with non-for-profits where we use our data science, analytic, and data engineering skills to help all of the communities we live and work in.
Secondly, colleagues, we're really here to recruit. So if you're interested in what we said and you think you enjoy working in large-scale, complex data problems, as you know, we have 2,000 jobs to fill this year, so we're actively hiring. Feel free to check out jobs.td.com.
And lastly, the one part to the equation that really enforces the reasons as a company we're all here is our customers. I'll leave you with a story that demonstrates it was a successful milestone for us. By bringing all of the data on our customers across channels, interactions, transactions, we were able to predict in times of stress and need the customers who'd be potentially entering financial hardship. We've got a capability within inside the organization that does outbound engagement and outreach, and we were able to engage with those customers, help and offer tailored custom financial products to be with them in their moment that matter the most. That demonstrates the power of data in helping our customers. Upal and I thank you very much for the chance this afternoon and look forward to connecting with each of you later on.
Thank you very much.
Thank you, Paul and Upal. That was great. Let's all welcome our next speaker, Jack Berkowitz, Chief Data Officer of ADP. Jack will tell us about achieving success with workforce data insights.
There we go. Hey, anyway, thanks for coming, and that was a good talk, so I'm a little bit nervous to follow. Anyway, my name's Jack Berkowitz. I'm the Chief Data Officer of ADP. Really happy to be here. There's a few ADP people around. They'll sell you payroll services right after this, okay? Now look, the company's one of the sort of historic companies for the nation, right? We've been around since 1949, and a series of firsts in terms of computing, right? First to process payrolls with computers. We probably still have it in our data center. First cloud-based payroll product. First HCM mobile app. And because of those firsts, we're always trying to look at technology and have technology come together. And for us, it's really about data. So we're actually the world's largest provider of HR solutions, right? So that whether it's payroll, whether it's tax, whether it's insurance, we're the biggest one. How big? 920,000 clients operating in over 140 countries. In fact, chances are in this room about this side of the organization is either getting paid by us or your taxes are from us. And for you guys, I'm really sorry, okay? And so it gets big, right? We process 38 million people every week or every month. We did north of 71 million tax statements, another 11 million 1099s. Just for information, there's about 150 million people that work in the United States, okay? So about half that US population goes through our system, and it's not just about payroll, it's also about people applying for jobs. So, everybody knows Indeed or, LinkedIn, but guess where all those job postings come from? They actually come from our clients pushing those into those systems to be able to hire. So we'll get 15 to 20% of the US population actually applying for jobs through us to our end clients, if that makes sense, okay? And so that information we have about people is always relevant, but over the past 2 years, I always keep saying this statement, people data has never been more important. And the news about the economy and the news about things can be overwhelming, even in financial services. But like I had my flight canceled yesterday coming out here. Why? They didn't have pilots, right? They didn't have pilots. Supply chain, it's because we don't have truck drivers, right? And everything we do is really about people. There's people here. And so how do we take a look at how do we use data to solve problems either for clients or for big banking investments or other things to drive the economy? So here's some data. Here's some data from our system. What you're going to see here, what you see here is actually the job postings and the background checks starting before the pandemic, in March, really it was the end of February 2020 until just last month. Really kind of interesting. You can see the surge and all the hiring. But if you actually look at it, we knew about 10 months before the Great Resignation started to hit that it was going to happen, because we saw in February 2021 the openings of jobs actually exceeded where they were before the pandemic. So we've known quite a while about what's going to happen. And in fact, the Federal Reserve taps our information to even set the interest rates that Junta just had to pay his mortgage for, right? So we can do a deal later, okay? And so much so that we actually publish a report called the National Employment Report that actually tells the markets what's happening in the labor market about 2 days before the Bureau of Labor Statistics. And the difference between our report and Bureau of Labor Statistics is ours is based on the actual data. In fact, the BLS is a survey from about 2,000 clients, or 2,000 random companies. They'll get back about 30% response rate. And what we know is 13 months from now, they'll get the actual data and restate to equal the data that we'll give monthly. Okay? So this information and all this data is now processing on Databricks. And now I'll spend the next part of the thing talking about how we got there. The other part of it is it's not just about the actual data off the paychecks or the actual data off the resumes, but even how you, as employees of companies, feel. So we process a lot of information, what we call voice of the employee or survey tools that we make available on our mobile app. So for this half of the people, right, if you guys get your paychecks from us, you probably get a mobile app that tells you what your paycheck is. You can actually respond to surveys on there. And what we can see, for example, this is the data from ADP's associates of their feeling about returning to work during COVID. What you'll actually see there, and we just showed you ADP associates, we actually have it for tens of thousands of clients and all of their people as well. What you can see is we actually see the trends of the surges of COVID in terms of how people feel about coming back to the workplace before the impact is actually felt with people getting sick. In other words, the beginnings of people getting sick in local areas and all these different things. So Google made press probably, 10 years ago about being able to predict the flu based on flu searches, but it still lagged 30 days, right? We can actually see the surges of COVID in people data happening in real time, and then have the impacts of those translated into either supply chain changes, into staffing changes. A lot of you are in financial services, into things you want to either, short or not short, right? So you can see all of that type of information coming together. Now, we built this data platform at ADP, and we built it for a lot of the reasons the guys from TD Bank said. We didn't actually have a choice. the explosion of information and the pace that we needed to move, we weren't able to keep up with using previous generations of technology. So we started this probably 3.5, 4 years ago, where we started to move our data platform to the cloud. We're in AWS, and then we started to assemble software, tools, and systems to enable a lot of different things. And now, off of that, layers of data governance, layers of machine learning models, and then use cases is how we drive our system. We didn't build just a platform, but we start with use cases. So starting on the left, we have a number of systems that are actually SaaS applications for people analytics, reporting, the compensation benchmarking, all generated that clients can purchase or subscribe to, and then get this type of insight, either inside of their application because they're doing HR or payroll with us, or as a service for them for other reasons. Then we have use cases to drive our business, sales, service, all of those types of things that are conventional, whether you're in financial services or you're in retail, all of those types of know your customer actions we actually build as well. And on the far end, it's how do we take advantage of new innovative use cases in data monetization, in workforce planning, in demand forecasting, to allow companies to adjust and react to really changing environments. And so, for example, one of the use cases over there is for a fast food chain to be able to determine where to stock different types of menu choices per restaurant based on the demographics and the changing demographics in their local area. So, we can see, for example, the fact is that everybody is moving to Austin, Texas, and we can see it in the data. And it's true, by the way, everybody's leaving the Bay Area and moving to Austin. And so you can see that, and then you can actually anticipate, make changes in your company's perspective as a result. Now, we started doing this with Databricks actually in January of 2021. We tried to do it in the cloud using some more conventional techniques, and we just weren't getting there. And actually, my associate is here, Vibor Shukla is here. So if you want to ask him any questions about this, he'll answer the questions afterwards, okay? So he was on me, let's try this. So we did. We started with one team. We got 3 workspaces up. And our very first thing to focus on was not building use cases. The very first thing we focused on was building Jenkins jobs to be able to deploy models and scale models, and for us to actually have control of the software that we were going to be deploying. So, I've been doing this a long time. I've been modeling my entire career. It's still software, right? And it needs to be treated like software. So that's the very first thing we focused on. Then over the course, and this thing blips in a little bit strange on the build, but over the course of the next year, we then accelerated all of the capabilities that we were putting together and working with Databricks really closely on. Our big thing was around ML flow. ML operations turns out to be one of the most important things for our company in terms of adopting the technologies. In fact, it's a board imperative for us. We're interested in the data governance. We're interested in making sure there's no data corrupted. But we're also interested in preventing somebody typing pip install some library that was actually compromised out on the web. And this is a topic that nobody wants to talk about in the ML community, but it's a real topic. And so our ability to get ML flow or ML operations together to be able to monitor the models, and not just monitor the models for data drift, but monitor them for bias, right? So we deal with data about people and the bias about how somebody might be offered something, whether it's compensation, pay, a problem with pay equity, or offering somebody a job, or better yet, holding it back, either based on their ethnicity, their gender identification, their age. Not only is it against the law, it's also ethically incorrect. And so we run a data and AI ethics board that then monitors and oversees our entire program. And I'm happy to talk about our ethics board, offline with anybody. So that's the time we spent in February, till February of this year. So where are we today? Well, today we've got over 25 different teams building models and deploying them in real time on our data platform. We have well north of, it says 1 petabyte here, it's a couple of petabytes worth of data, 200 actually terabytes of data flowing in every day. And all of that happened because in the course of thinking about technology, it turned out we actually changed the way we operate as a company. Our data platform, continues to be there. You'll see that there's pieces from Databricks, there's pieces from other vendors, because at this moment, right, still some of that best of breed is needed. Things like security, for example, Immuta, we're a big partner of using Immuta for security enforcement, and all of that comes together to allow us to build things. But the most important part was our adoption of our single global data platform hub and spoke model. So rather than just being a central team, we decided to do something different. And we actually decided, no, we're not going to build a massive central team, try to control everything. Because we'd seen the lessons of common object models failing, common data models failing, right? The thing to us was if we had built a platform and we had done it as a product, the way we would measure the product success was the uptake by others. Just the same way as Junta was talking about the acceleration of clients using Databricks, that's exactly how we looked internally to our system. So what we said was, we're not going to tell you what data to bring. We're going to create a place for you to come and share data. And what people did is, everybody's in silos. No, that's my data. I'm not going to share it. So we said, tell you what, there's a public space and a private space. You want to come in and put your data in the private space? Because your silos, protect it, but you can get other people's if they put it in public. We'll create that environment for you. So we set that up. And what we saw was exactly that. We took some central data, made it available publicly. Everybody came and brought their private data. They didn't want to share it. But then over time, they started to. And so now what we have is the data for 25 different business units or groups actually being shared throughout the system. Now, we're still struggling with semantic models and everything else. The world of data mesh actually isn't there today, right? And we still need to have things so that we get common things. But that data is there and it's being shared across the organization. What that allows us to do now is to uncork a whole bunch of new use cases that, again, Junta hit it, right? All of a sudden you get this happenstance of an explosion of use cases for the upper market or for increasing your sales or your capabilities. And so we ended up, and we're now working on coming to market with a whole bunch of new use cases that we hadn't been able to anticipate or anticipate building if we hadn't had this explosion of information across the company. It's almost so fast that I can't hold it back. And so now it's like, let's let it run and see where it goes. And just like TD Bank, if you want a job working on the biggest data set in the world, and we do mean the biggest data set, the advantage is that we actually know what your paycheck's going to be before you come in. So negotiation isn't so great. But we have over 9,000 technologists, and we're happy to be here today. So thank you all very much.
Ladies and gentlemen, here's Jeff Parkinson, Vice President at Northwestern Mutual, and he's going to come and tell us how they use Databricks to fuel a data-driven ML ops ecosystem.
All right, is this on? Can everyone hear it? All right, we're in business. So I'm Jeff Parkinson, everyone. The Vice President of Core Data Engineering, it says here, for Northwestern Mutual. So I have 30 years of experience across financial services, retail, media, insurance, sword swallowing, lion taming, and a few other industries as well. I was kind of horrified when I was writing that 30 years of experience. I'm very old. I know I don't look it, but here I am. Luckily I work for a company that's much older than I am, so it makes me feel very young, working for them. So NM has been around for 160 years plus. People to be financially secure and families financially secure. Also there's a lot legacy goodies waiting for you when you come and take a job like this. I've been there 7 months. I'm still discovering them. A lot of them are sitting over here. I was really thrilled to join NM, and one of the reasons I was is that it was a data-driven company, and it really it comes home when you notice that like in the last 3 years they've doubled the investment in data. They really want to be a data-driven company, and for me that is all about putting data science in every decision that the company makes. And so, I take it all very literally. And then that's why we're going to talk all about MLOps in this discussion. So what is MLOps? The way we define it is really the confluence of DevOps, data engineering, and data science. So the DevOps aspect is to enable the data scientists to bootstrap the cloud resources that they need. It's for the data scientists to get clean data in and be able to train and create their models from it. And it's for the data engineering group to then take that data and operationalize it and make it available to everybody for usage. So why do we use MLOps? A lot of data science teams, they'll have data in all kinds of little places squirreled away. They'll have, on their laptops, they'll have it in little non-prod databases all over the place. Having a centralized MLOps team starts to get away from that, right? It's basically bringing that data in, making it collaborative across these different groups. We have 150 data scientists at NM. So, there's a lot of different groups that want to access that data. It helps with compliance. The privacy people love the fact that we're bringing all that data in, making sure it's not squirreled away, and you have PII sitting on people's laptops. Obviously, it's a cost reduction to have all that in one place and not having we have all kinds of little Netezza data labs living all over the place. And in general, it's allowing data scientists to innovate and not maintain all these models that they've created over the years. That's what we're really after here. To delve into it a little bit more, looking at the data ecosystem, where does MLOps kind of light up here? It's both in data acquisition and data prep. Those areas can be up to 50 to 60% of the time to bring a model to production. We're trying to reduce that to as close to zero as possible by providing that data on a regular basis to those data scientists. Also, it's deploying those models to endpoints. That's not something that data scientists typically are good at. That's something that we're trying to take on and make part of the production process. And then in addition, ML isn't ML unless you have a feedback mechanism coming back in and helping to train those models, and making them unobserved and working through a machine. So that's also the province of our MLOps team. So why are we doing this at NM? How is that helping us? So where we're using ML, first and foremost, is in our straight-through processing models. That is allowing us to automate the entire underwriting process and cut down both on cost, increase efficiency, and really move us to the forefront of our industry. We also have introduced in the last couple of years personal investments, as well as other products across the life insurance spectrum. We have cross-sell propensity models for all those products across all of our current clients. The next best action is the optimization of that, and we're starting to customize our website with that MBA model. Lastly, we have a customer lifetime value model, which essentially looks at the potential value that these customers can have for us, and we're also using that as a variable in our models and also to further personalize. But what are the keys to MLOps success? For us, it was really trying to keep it simple at first. MLOps gets very complex very quickly on its own. At first, I think a lot of the technologists wanted to bring in as many open source areas as possible. You can certainly do that in Databricks. What we're trying to do is go back to basics, just concentrate on simple ingestion, on cleansing routines, and making that data available for training and for exploration. That was a big learning that we had at NM. In addition, we wanted to make sure that that data is clean. You can very quickly lose credibility across the organization if you're putting out data that isn't cleansed and isn't ready for use. And finally, every business use case that comes to us is looking for data in real time. For us, we always challenge that to see if the use case absolutely needs to be in real time, because the support model that comes along with that is obviously very onerous. And is something that, while we do have ODSs that we utilize across NM, we want to make sure that we're doing that for the right purpose. In addition, we're also hiring. Basically, this is becoming a job fair. So, afterwards, anyone who wants a job, I think you can basically talk to anyone in the front row here, and we're willing to. We will start a bidding war for all of you guys. So, look forward to that. And as the liquor flows, I'm sure the price will go up. So, don't be the last man standing. Anyway, thank you very much.
I am thrilled to introduce you to our next speakers, since this topic is near and dear to my line of business. Gepping Chen, Head of Data Engineer at Geico, will talk about the rapidly accelerating field of IoT-based telematics in insurance. Please welcome Gepping.
Hello. All right. It's really a pleasure to be here with so many people in the great city of San Francisco. Really enjoying the weather and the vibe, and so many like-minded people here. My name is Gepping Chen. I'm here to talk to you about a very particular data application, which is dealing with IoT data streaming and its manifestation in the auto insurance industry. Okay, so we have actually a lot more device interconnected things since 2008, and that was like 14 years ago. And today we have even seen a much more proliferation of devices in our homes. And when it comes to getting your home rigged with smart devices, I'm not the craziest person in this room probably. But whenever I open my mesh router, it's not uncommon that I see about 20 or so devices in the room, like in my home. And I really enjoy, for instance, watching my dog lying around or playing outside using my Blink video. And imagine how much data that has generated by just that simple video viewing. So it's a great market, and in the commercial world, we are seeing even more IoT embedded in the critical business processing, and also impacting our lives, and also impacting the company's bottom line. For instance, in the pharmaceutical and vaccine industry, we are seeing a lot of use of IoT sensors to monitor the temperature, and also send alerts to the management when the temperature is outside of the acceptance range. And in the supply chain, it has long been using sensors to track the progress of your delivery, and that was like already 10 years ago's technology, right? And also real-time routing the trucks based on traffic condition, like weather and just traffic condition. And wine and precious goods have been using those sensors to monitor the humidity and also the temperature of the wines and those precious goods, and alerts when the humidity is actually outside of the range. So it's already impacting our lives a whole lot. And the market is actually pretty big, $15.5 billion. That was 2020, the global IoT insurance market. And that's about 1/5 of the same year global insurance market. And it's growing pretty fast too, 66% annually. But look at this, 30% of potential reduction in claims. And why is that? Because I'll talk about it more, but telematics can actually change your driving behavior, makes you a better driver in terms of keeping the safety. And also, it can kind of detect in case of a crash pretty accurately because of the accelerometer embedded within the telematics devices. And it's also one of the top leading trends of insurtech investment, number 4 actually in the chart. And the insurance telematics is actually probably the most prominent use of IoT in the auto insurance. At the very beginning, it was just devices either built into your car or attached to your car, sending accelerometer information so that it knows if your car is making an uncontrolled cornering or hard braking or hit something, right? But with the widely use of smartphones, the data can actually be generated directly from the phone. And in a lot of the cases, the telematics is actually using the smartphone because it has all this gyroscope and accelerometer devices. But why telematics, right? So for you and me as a consumer, one of the biggest advantage and benefits for us is to make our driving better and make ourselves more aware of our driving. I'll talk about that too. And potentially reduce our insurance bill. So when I sign up for Geico's telematics, I receive a pretty good amount of money back because the fact that I signed up for telematics is an indication that it's a favorable selection as opposed to a adverse selection, which insurance company dislike, right? And it's also better customer engagement, right? Imagine how often you use an insurance app, right? It's only in case of claims or during the annual or biannual kind of like a 6-month renewal time when you realize that I gotta pay my insurance bill. So the interaction of that app is very little compared to apps such as Amazon, for instance, or Netflix, right? But having telematics within the app actually increases the way our customer interacts with our app, and more traffic means more business. So that's the truth in nowadays. And as we are using this app, we also are aware of our own pricing, right? So I know why I'm being priced lower, for instance, because I have been really paying attention to my driving, not picking up my cell phone once in a while I was driving. So, and it also helps you to test helps the insurance company to help your in case of need, because like I said, it can detect a crash pretty accurately. And for the insurance company, right? So the benefits are also paramount because, like instead of traditionally we rely on customer demographic data, vehicle data, claims history to price a customer. I mean, what are those information? These are just indications of your behavior. But what if we can monitor, we actually see your behavior? So it provides a much more precise and accurate way to assess the risk of the insured. So Junta was talking about hyper-personalization at the beginning, right? So this is a way of hyper-personalization for the insurance company. And like I said, it also creates a favorable policy selection. And especially when nowadays there are many concerns of the regulators banning the use of many attributes to price our customer, telematics becomes a great alternative and much more precise one for the insurance company and also for our customers too. But of course, it comes with potential concerns, right? Like with any IoT devices, like sometimes I realize that my conversation at home might be heard by my the Google Hub or the Amazon Echo, right? And sometimes when I look at my Roborock robot to clean my floor and see that my floor plan is actually visible from remote, and I'm concerned that the company is also seeing my floor plan and thinking about some other ways to earn money. And of course, the technology cost. So this is a screen of the Geico telematics. So if you look at the screen, the first screen is my score detail, right? I have been pretty good at focusing on the road and on the wheel, right? I haven't done many occasions of looking at my cell phone. And the trip detail too, like on this particular trip in the middle, I have one heartbreak. And mind you, this is not my typical trip. I don't have a lot of heartbreaks very often. And the third is my family scorecard, because everyone in the policy need to sign up for telematics. And what can I say? My wife is the top, and my teenage daughter is second, and I'm the lowest. So I'm very proud of my coaching skill for my wife and my teaching skills for my teenage daughter. Because I taught my teenage daughter to drive. And also, before we sign up for telematics, right, I have been nagging my teenage daughter to be careful whenever she wants to head out and drive a car. And now that I see this, I have all the confidence and trust in my teenage daughter's driving skill. So telematics, in conclusion, makes me a better family member and an individual. So sign up. So the telematics pipeline. What are we capturing, and what is the pipeline? How does it work? So as soon as the trip completed, all the sequence gets kicked off. Data gets ingested, and we're not talking about just one piece of data. It's actually a lot of data. We have the trip data. We have like the starting location, the destination of the trip, duration of the trip, where is it happening, and drivers data, right? We correlate the driver's information from the device's information. We have the vehicle data, sensor data from your cell phone, and we also go out and get weather data for that location, because different weather would present different kind of risk factors for the trip. And also traffic data, right? Sometimes the road gets congested, so all this data needs to be ingested and then merged together, get curated, and then to be made sense by extracting the features from that piece of data, and then we send to our scoring model to update the score. So pretty much after you finish a trip, you will see from your cell phone your score of the trip. If you had a heartbreak, if you have any hard cornering, something like that, right? And if we go in and zoom in a little bit more on the pipeline, this is a logical pipeline of how we process telematics. So we have the IoT sources. Some of them will present themselves as streams. Some of them present themselves as files, because there's a lot of data, especially when it comes to really big trips, right? When you're driving nonstop for 3 hours, the trip becomes really huge. And also, some are obtained via APIs. And when this data got into Azure, we're using Azure's data ingestion services and pipe them into Azure Databricks, where all of the data correlation, aggregation, feature extraction, all these are happening with orchestrated. And the pipeline has been there for some time, and we realized that we can benefit a lot from using Delta Lake because of the nature of all this combining stream and batch and using and the need to do a lot of asset transaction as well. So we are actually looking actively into Delta Lake and using the Lakehouse architecture to make this pipeline a lot more effective and efficient. And once the scores and the curated information are done, we fed them to scoring for our data science to improve the model, and also for reporting to the business. And we are hiring too. So our business is driven by data and also driven by our passion to exceed our customers' expectation. So if this is something that you are passionate about, come join us. Thank you.
Now, here's our next speaker from global consultancy Ernst & Young EY. Please welcome Ken Priyadarshi, AI leader for EY Global. He's going to be talking about building an intelligent data mesh.
Hello. Can everybody hear me? Yes, that's great. So this is a fairly geeky topic, building not just a data mesh, but an intelligent data mesh. So I will confess first and foremost by saying that I'm not a CFO or a finance person. I never took a finance class in college. I am a computer science major by way of education. And so I was quite surprised to actually get invited to come talk about the work we're doing in the context of the CFO business problems that need to get solved. But I was watching an interview the other day of a very famous, still a very famous CFO in a major hospitality Fortune 500. And she was asked the question, hey, what are the CFOs of tomorrow? How are they going to prep for the world that we're living in? And the first thing she said was, CFOs need to sort of be highly educated on data and technology today. And I took sort of that interview and I thought about that and I said, oh my God, times have really changed. Because when I graduated with a CS degree 20 years ago, by golly, I had to hide the fact that I was a CS major when I was talking to CFOs or chief strategy officers. And so, we've come sort of a very long way in this space. And I think that the group that I'm sort of currently working in, called EY Technology, is sort of a testament to the fact that so much of our own industry when it comes to management consulting and professional services for the CFO suite in itself as a business is sort of transforming itself. So I want to give a shout out to some of the teams that I work with that are building, of course, what we always do in professional services firms, which is largely building data and AI platforms for CFOs. So we've got, I think, the customer DNA team, the Fusion Data Fabric team, the Shazam team, all doing data and AI work for our clients. But what's also really interesting, and this is a data nugget that I got the other day, was when you look by sector, the IT spend or the technology spend, the second largest spend in the US and the growth in that space after financial services is actually professional services. And this sort of blew my mind the other day and sort of is again a testament to the fact that we're living increasingly in a world where professional services, management consulting, and increasingly product engineering and technology is sort of coming together. And so, I used to think I was popular with software vendors because I was fun and easy to get along with. It turns out it's just because we have a really high IT spend in professional services. Who knew? But as I began my career as a computer science major working for the CFO suite, one thing became very sort of self-evident, and that was that there was a common business problem pattern, a template that we saw for CFOs over and over again. And I think Junta talked a little bit about that earlier. The template is CFOs unleash an army of analysts to go get the data, process the data, create insights, and then they have actionable results upon that. One of the largest transformations that I was involved in early in my career was for the CFO of a major telecoms giant. And I was fascinated by the fact that the entire transformation was built upon data and analysis that the CFOs were doing using essentially 10 slides worth of aggregated data. And this sort of blew my mind. I said, well, there's all this nuance to this data. Are we really going to make these incredible decisions at the C-suite for a global Fortune 500 with the data and the tables that are in 5 slides, 10 slides? Is that really correct? And that was exactly the moment, and I'm still traumatized by it, when the CFO said to me, hey, you're a CS major, why don't you get out of the CFO department and go talk to the IT department, get me the data, get me the granular data, and solve these problems for me. And that sort of set me off to a career trajectory, which is, I think, where we are today. And I think we're all in this community, I think, somewhere in the middle between the CFO suite solving some of these business problems and solving these increasingly integrated data and AI problems. So I'm going to give a case study of something that we recently got involved in that involved, I think, building something that certainly ticks the boxes for when we start talking about data meshes or maybe distributed ML computing. Your tax department. This is bear with me here. I will not belabor this for too long. But one of the things that CFOs are really interested in right now is, especially if you're a Fortune 500, is something called the value-added tax. It's essentially an indirect tax. 160 plus countries are involved in it. And it's a form of indirect tax. You can think of it as a sales tax, except it's actually calculated at different points of the supply chain. And it's particularly growing when it comes to what we see in the regulatory body on the other side of the Atlantic. Now, think about the supply chain system shock that we live in today. So suddenly you realize, hey, the complexity of the problem we're talking about. Supply chains are more disrupted and more complex than ever before. I began my career, and one of the first projects was actually looking at supply chain data. And by golly, I can tell you nobody from the CFO department ever called me when I was an analyst looking at supply chain data. It has never been more popular to work in supply chain data analysis in the CFO department than today, and I wonder why. And so, hopefully this is sort of a really interesting story about how integrative our field has become. Who knew that the tax department, which makes these calculations on a global supply chain, so you've got to look at your inventory, you look at all the different connection points in a supply chain, is suddenly very relevant from a CFO suite perspective. At our firm, we actually had multiple ways of delivering the service to our CFOs clients in the context of value-added tax calculations. And we said, hey, wouldn't it be interesting if we could just simplify all of this as opposed to having all these proprietary systems that we've built in-house to do tax calculations, value-added tax, et cetera. And the way we attacked the problem was essentially by saying, hey, every country has its own localized regulatory scenario that necessitates these VAT calculations. So there's a very domain-specific way of solving this problem in every country. So domain-centric nodes of data computation. Hopefully that's ringing a bell here from what you've heard in the talk here, right? Now, also very often at our client, we had a very heterogeneous data environment, right? You have data silos all over which have the relevant supply chain data, the finance data, the VAT data, the ERP data, et cetera. So again, a construct like Lakehouse may be very helpful in essentially bringing some of this together. And then the last piece is, as we are essentially building intelligence around these constructs, we essentially move towards creating a topology very much analogous to a data mesh, and if you add algorithms to it, an intelligent data mesh that specifically solves this very complex tax meets supply chain meets CFO tax optimization problem. The big idea here is that we've historically solved this problem by just throwing humans at the problem, and then after throwing humans, very often people start creating their own SDK, their own toolkit to come up with the analysis necessary to do these tax calculations, value-added tax calculations. And so the first thing we said was, could we build a business application with Lakehouse underneath it? And the front end can be a series of micro front ends, or it can be a low-code experience layer. In this particular case, we went with a low-code experience layer, Lakehouse layer in the middle, with obviously connectors directly to the ERP systems of the various clouds. And this effectively helped us create a full-blown business application to solve and optimize and advise our clients on the value-added tax optimization problem in a distributed way. Now, Fortune 500s tend to be quite siloed. There are thousands of legal entities involved. How do you connect all of this together? Well, again, a Lakehouse plus data mesh topology is particularly relevant. And I think the next big thing that we're really focused on is saying, hey, we have all these tax practitioners giving advice using this tax VAT business application. Wouldn't it be interesting if we could pair them up with learnings from all these different distributed silos of VAT calculation data, create a recommender system, and essentially augment the knowledge worker with the ability to basically deliver higher value? If you do that, not only do you democratize expertise, but in the world of managed services, professional services, one of the key KPIs is essentially your margin per engagement. And as Junta talked about earlier, it's all about sometimes optimizing the margin per engagement as we give advice and optimize the tax meets supply chain VAT problem. So perhaps what was really interesting about this journey is the fact that we didn't just build a data problem solution. We in fact built a business application that just happened to be using the lakehouse, that just happened to be using a mesh topology, that just happened to increasingly being an enabler to next generation recommender systems for human augmentation. And so is this not perhaps the beginning of the way we used to talk about, let's just say, a major SQL vendor in the 80s and the 90s? When you think about the way the ecosystem has evolved, started with the mainframes, then it went to SQL, now it's a whole bunch of other things, but we don't talk about SQL as something that belongs to a vendor anymore. It's invisible. It's inside every IT business application that you build out there. And so my perspective is it not potential possibility that in the next wave of business applications that we're going to see, we're going to actually see lakehouse and mesh topologies become almost invisible in every major data-intensive business application that we build. And for that to happen, I think it's important for us to think about the problem that we've begun with here as not just a Spark problem, but a Spark plus Delta Lake problem, Delta Lake plus MLflow problem, MLflow plus all these adapters and connectors, as Junte was talking about earlier, to the broader ecosystem that makes up our broader Fortune 500 technology ecosystem. I think one of the acid tests for me in this space was when we began this project, a lot of people called me crazy and they said, hey, you're using essentially an OLAP technology to solve an OLTP problem. And when we optimized our cluster, we were able to get just as good performance for very write-intensive work in our mesh topology. And so I think that a lot of these problems, the ability to increasingly adapt to hybrid computational workloads, the ability to address different kind of models, the ability to connect to different ecosystems, now more than ever needs topologies and frameworks and platforms such as the Lakehouse to make that happen. Now, what are the challenges with perhaps some of this? And I gave a talk on this many years ago around the fact that, hey, system integrators used to get hired to integrate two pieces of technology together. Well, increasingly, I think it's now about actually integrating ecosystems together. There's this great book that I picked up, and it's called The Accidental Ecosystem. It's essentially this premise that, hey, if you look at the flora-fauna ecosystem of a city, it's just as diverse and increasingly crazy as what you might see in wildlife. And I like to compare that actually increasingly with what we are doing here in the data and AI ecosystem in Fortune 500s. I think that if we look at our journey, this community's journey, everything that we do together, we're creating a new category of business applications and talent. And that talent is increasingly about bridging the gap between really domain-centric business problems, such as value-added tax, to being able to generate the kind of ROI that our customers need. And so, I think that the intelligent data mesh to me is not just a topological construct. The Lakehouse is not just a platform, but a way of thinking, a mindset, and increasingly, I think, a very domain centricity meets AI plus big data way of solving problems. And I think the next generation of leadership is going to be about not just us as members of the Spark community or the Databricks community, but it's important for us here in this room to think of ourselves as custodians of business transformation, because the next wave of business transformation is going to be driven by talent, such as the folks in this room and the thousands that are online right now that have integrative thinking and bring domain, distributed computation, and hybrid workload computation together. So I hope you're all excited about solving these kinds of problems. And if you are, just shoot me an email and maybe we'll talk about it over coffee someday. Thank you very much.
Thank you, Ken. That was very insightful. Our next two speakers are from Standard & Poor's newly formed business unit that specializes on ESG, called Sustainable1. Please welcome Gary Jones, Chief Data Engineer, and Mona Soni, Chief Technology Officer from Standard & Poor's Global Sustainable1.
I am audible? Yes, I am. Cool. Well, hello everyone, and I'm sure you guys have enjoyed the session so far. We're going to take you down our journey at S&P Global. So before we jump into what we do, our problem statements around data, I'll give you a quick introduction, a very high-level view into what we are doing, what we are trying to achieve from a business problem aspect. So we are Sustainable One at S&P, and S&P Global is a financial services company. We combine data, technology, and our own expertise to unlock insights into that data and serving the entire financial industry, varied range of customers, and serving their needs to achieve their own financial goals. What are all the capabilities that S&P has? So we work in the energy transition space. We have our ESG benchmarks. We are in the emerging market space. We are into private market data space. We provide engineering solutions and expanded view on mobility. Since S&P has been around for a very, very long time, it was McGraw-Hill in the past, and recently we went through the merger with IHS Markit, so we are a 50,000 plus companies. It's a big organization. But since 1999, ESG and sustainability has been a very important topic for S&P. We launched since the beginning of 1999, launched the S&P Dow Jones Indices focused on sustainability. Since then, we have done various acquisitions. We have launched many more indices. And then last year, Sustainable1 was launched. So before that, all the divisions, various, like in the previous slide, all the capabilities that we talked about, every division was doing something on their own on ESG. So as a strategy for the company, we brought it together under the umbrella of what we are now calling as Sustainable1. And since the forming of Sustainable1, we have acquired another company in the beginning of the year, the Climate Service. But what is ESG? We hear about this term a lot. So people who know, that's great. But to set the context, E refers to environment, and the various aspects that we cover under environment are like greenhouse gas emissions, biodiversity, water and waste management. Under social aspect, which is the S of ESG, we look at diversity, human rights issues, consumer protection, and the animal welfare. So this is not an exhaustive list. I'm sure there are many, many more, but this is something that I picked up from Wikipedia to set the context. And lastly, the governance, the G in the ESG. Looking at how organizations are being run, how are the companies being accountable for their own practices? So what's their management structure? What are the employee relations in those companies? What are the compensations for executive and employees and the comparison between? So it covers a broad spectrum of topics. Now with that understanding, ESG market is exponentially growing, and with pandemic and with the recent things that are going on with the war and everything, it has put focus not just on the climate topic, because that is on everyone's mind, many more aspects of ESG. So what are the customers looking for to help in this space? Everyone is how we figure this out. So they're looking for mainly evidence-based insights. They want to understand what's going on. They need high quality data. They said there's a lot of data being collected over the years and years around all of these topics in ESG, but they need a higher quality data that they can derive insights. And then being able to run advanced analytics on top of that. So these are the primary needs of all the customers that we see in this ESG space. Now, how is Sustainable1 supporting that needs of our customers? So this is our strategy based on which the Sustainable1 was created as a business function that supports all the other divisions within S&P Global. So The goal is here to have a one S&P Global-wide strategy. We have a one house view. We are able to provide that global customer experience to all the customers who are coming to S&P for their ESG needs. We are proactively working with the regulators because remember, like, ESG is not regulated right now, but the regulations are coming soon. As similar to financial services industry, you all know this, like the way it's regulated, the ESG space would be soon regulated. So how do we support and be champion both our customers and their needs as part of those upcoming regulations? And then being able to have that unified roadmap backed by a uniform technology and a data strategy. And then at the end, like how we are approaching with that, like even with our insight, our thought leadership, because I had to bring in the concept of ESG to this forum, because this is new for everyone. So how do we guide even the people that what does it mean? How does this impact everyone? My dentist recently told me, is like, in future, maybe that every person would have their ESG score. Like the way we have our credit scores, we might have our own ESG scores. Like what as an individual, like are we living a sustainable life or not? So not an S&P comment, it was from my dentist. Disclaimer, yeah. So who are our customers? Who are we doing all of this work? Who are we serving? So what you see on the top is all the divisions that we have within S&P. And then we are serving like individual savers like us. We are serving asset owners, the asset managers that work with different companies and financial institutions. We are serving corporate bonds, corporate management, as I said earlier, like to help set the standards and with the regulators. So these are all our customers, and we serve them directly, and we serve them through all these divisions that we work with within S&P. So what are our data offerings? There is a lot of data points on that slide. I'll touch on few that we have 2.7 million assets that we evaluated for just physical risk related to the climate topic. We have 110,000 companies that are analyzed on climate-related credit risk. And the most fascinating figure there is like we evaluate and we go through 700 billion data points in our overall research universe just for ESG. And like that number is really growing exponentially because our customers are not looking for like a year, 2 year, 5 year, 10 year foresight. They're looking for what's going to happen in 100 years. The physical risk of like if this data center is at risk in next 50 years, 100 years. So customers, their requirements are very, very different and very, very long term here. So what's the opportunity? Like why are we talking about this? How does Databricks come into this? So what are the opportunities? So what we really need to serve this space, we need a platform that is centralized and streamline all these processes. We want to accelerate product development. Like we have been like, if our stakeholders wanted, we should have launched everything 6 months ago. But we are a new organization. I've been in this role for 8 months now. So how do we accelerate whatever we want to get out to our customers? And we want to minimize definitely data replication. 700 billion data points. Imagine replicating it across each division for them to be able to bring in that insight, like exponential cost. We don't want that. So how do we minimize those costs, but still have maintained governance that someone is able to access the data? Are they authorized to access that data? And then being able to serve all the divisions that we have. It's a very important piece for our evolution that we should be able to very effectively share data with all the other divisions to meet their own needs. So I'm very proud to have our chief data engineer, Gary Jones, with me, who's being a sport because he's coming from London. He flew in yesterday, and it's past midnight as per London time zone, so he's going strong. So over to Gary to help through how we are approaching our solution. So thank you.
Thank you, Mona. So why Lakehouse? I guess this might be a question that many of you have posed or even answered for your own platforms. We took a look at what we need to do for our strategic platform. We set up with the remit of building the future platform for ESG data within S&P. But we had to look at what we were doing with that data. And this very high-level model of the data lifecycle, pretty much encapsulates everything that we do. We are the front door for all of that data. We collect a huge amount of data, as Mona has said. We have to curate that and store it, provide access to our analysts, to our data scientists, to the transformations and methodologies that they build. We have to run those as a production workload, and we have to deliver the data throughout our organization. So we needed something that will give us everything in those lifecycle steps, and we needed the strategic platform, the go-forward technologies. Casting your mind back to the point of Mona made about the timeline of Sustainable One. We're a new organization, we're building a new platform, but we have a huge amount of legacy processes, existing data products, existing staff, and how they curate the data through our processes. So we've got to balance those two worlds at the moment. I'm afraid the grays on our slides haven't really worked on the presentation. You can't see much of the architecture here. But as a very high level view, the platforms we are building is mainly the data and analytics platform in the center of this diagram. It's sandwiched between a very transactional collection system and surveying system that gets us the raw data, and the egress platforms that are within the different divisions across S&P. We have requirements here that perfectly encapsulate what the Lakehouse gives us. We have a single storage location. We've built capabilities on top of that that give people rules-based access to process data and to move it around the organization. We've got a security layer to allow humans access to all of this data whilst stopping them from generating data that goes out the door to customers. It all has to go through a machine process. We've got job orchestration that gives us everything from simple scheduling to very complex workflows. And of course, on top of that, all the tools that data scientists and analysts need. Now, we've not been, as Mona said, we've not been at this very long, but what we have learned is quite important. We've managed to go from a standing start without an AWS account, without a Databricks workspace, a brand new Scrum team, and they've delivered business value in the first 3 months of work. They're delivering a self-service platform in 6 months. And that's only been possible because we've been able to avoid lots of integrations. So we've used, wherever possible, out-of-the-box tools and features. Now, there are a lot of tools and features. Some are good, some are very good. But they're all available immediately. They're all being iterated, and they're all being improved. Those tools as well provide an awful lot of familiarity to our users of legacy systems. They can use SQL statements. They can use BI dashboards. We've put them behind a single corporate sign-on to one tool, to one interface that they can get to use. So there isn't a huge amount of work for them to be retrained to use that platform. And of course, bringing everybody onto that platform is essential for us to meet the huge growth in data sets and data products that Mona has outlined. It's the only way of us to scale. And really, we're really excited about the next chapter as well. Being able to share data in a very efficient way across the organization is the headline of our remit. Once we've generated it all, we need to be able to deliver it. And delta sharing is a way for us to do that. It looks great from an S&P-wide corporate approach because the whole organization is using different Databricks workspaces across different divisions. This Unity catalog and delta sharing ties all of that together and means that we have a very efficient one S&P Global solution. I'm going to stop there. I'll give you a minute and 20 back, unless anyone's got any questions. Thank you.
Thank you, Mona and Gary. We are rounding out the day with the final sessions talking about capital markets sector. From JP Morgan Chase, here's Arup Nanda, Managing Director, CTO of Enterprise Cloud Data Ecosystem, who will share some best practices on managing global enterprise risk.
Hello and good afternoon. Can you hear me okay? Looks like it's fine. So my name is Arup Nanda. I'm the Chief Technology Officer of the Enterprise Data Cloud offering at JP Morgan and Chase. One thing I have been told to tell very, very clearly that everything I say today is entirely my opinion and does not necessarily represent JPMC or his associates or subsidiaries. So just to please keep that in mind as well. What I'll be talking about today is the trends I see in the financial services industry in the data space, and that's the key word here. Let's see the first one here. The first one, and most people talked about a lot of things about data management and in the FS industry. The specific thing I want to talk about is risk management. That probably applies to pretty much all the companies in this. Every financial company, they manage the risk. We give something out as loans, we get some deposits in, and we have to make sure that the cash reserves we have sufficient reserves in case people come and run the bank. We have enough capital to have it. So our risk management has multiple functions. One is liquidity, also country specific. We operate in many countries around the world. So each country has its own reserve requirement, et cetera. We have to make sure that we comply with all that. And finally, we talk about economic slowdown, which is absolutely happening right now. We have to make sure that we have, when the deposits come coming, inflation increases the rate, et cetera, we have adequately prepared for all the risk functions here. We're a 130-year-old company, if you think about it. And the problem with this company is that over the period of time, the risk profile itself has changed significantly. 130 years ago, people are doing is probably some kind of a calculation by paper, probably. And eventually they moved into PCs, which is some Excel, not Excel, Lotus 1, 2, 3 probably. And after that, probably Excel, et cetera, doing that. And obviously a massive company, which is impossible to do that on the Excel spreadsheet either. So risk management function, that's particularly challenging for many financial services industry. So what are the 4 things I want to make sure that we get out of it? Number one, opportunity is that identify the patterns of here. And that's a key word here, patterns. It's not data itself, but the pattern in the data, how can I identify that? In the past, people used to look at the data and figure it out by looking at it. And as the data volume increases, that simply becomes impossible. There's still some people probably get that. If you have seen the movie Accountant, you can see that they can write stuff on the whiteboard and on the wall of the conference rooms and they get everything out of it. But most people aren't exactly that. So identification of the pattern has become really significant in risk management. Number 2 is that that becomes another problem. De-identification. In financial industry, you can't just simply refer a person even though they have the same account, 2 different accounts, the same person have 2 different accounts in 2 different lines of businesses, we cannot reference them. So Junta, for example, has 2 accounts, one for say checking account, one for loan account. Even though we know the same person, SSN number is exactly the same, we cannot reference that unless he has given us permission to do that, something called affiliate sharing, which applies to all the financial services industry. Because that. So that rule says we can't simply combine that. But if we don't combine that, how are we going to do the cross-product marketing? We can't do it. So we have to de-identify the person to make sure that we remove all the identity of the customer from the data. So we can use it for ML, but we can't identify that. When we finally get an outcome through ML or something, we send it to a third-party company who has the responsibility of merging that with the actual records and send out the mailing. We do not know that exactly who the person is, etc. Number 3 is that risk is always going to be there. But if you don't take the risk, we don't get the return. It's very simple. So the trick is to make sure you maximize the risk and the returns, that ratio, actually it's opposite. Returns to risk ratio, you have to maximize that. And to do that, we have to create some kind of systems and processes to do that. And finally, a company of a size of ours, any company of that, you get the data from multiple sources. And not only multiple sources, those sources are also disparate. All different systems. In fact, I was in a panel earlier, we talked about it. We are a 130-year-old company, as mentioned, that you have lots of systems. You probably name it, we have it, that system. You bring up a technology, we probably run that today in the bank. So that's the key word here. If we do this, if we build a bridge to every possible technology to go and make that and bring it to us, we'll go nuts. That's not something we can actually practically do. So we have to make sure that we take these systems from multiple systems, multiple technologies. The people who have built all those systems, they're probably gone by now. We have to make sure that somehow we can extract the value from it and put into a system. How do we do that? That's what I do for here. The first trend I saw, which I think I've been seeing for quite some time now, is that the line between data analytics and machine learning is blurring. There is no difference. If you can get the data, clean it, do the quality check on that one, and do all the different things you do, the lineage, etc., and you move that into an environment where you can do analytics. Why not use that for machine learning as well? And likewise, if you do something for machine learning, why not do for analytics? It's both ways. So that line is blurring. And that's something we see a trend happening. So anything you create will be used for both of them. So the word use case for machine learning, use case for analytics, no, it's not. It's a single use case. That's a data use case. Likewise, ML ops, data ops aren't different. They're the same ops itself. That's on the trend we're saying. So that being said, here are the needs. First of all, everybody wants super quick analysis. They won't do, in the past, machine learning models. Typical machine learning engineer, not engineer, data scientist, they used to give a model and run it and go home. And perhaps come back the next day, and possibly and hopefully that analysis would be complete, the model will be trained, and they get it. If not, they retry it. Experimentation required that. You can't do that. You have to get that things done super quick, analysis. If it doesn't work, you do another experiment. That doesn't work, you keep on doing over and over again. So they all need super quick analysis. And also another thing is that they're not willing to wait for something to be refreshed in a periodic intervals. The gone are the days where ETL was the king. You wait for an ETL job to run, extract from something, load into a machine learning environment as data, retrain your model, wait for everything to be complete. They can't do that. We have to get that thing from very, very quickly done. And another thing also, and it's also interesting probably in our industry, but also applicable to the thing as well, reproducibility of this. We have to produce the evidence that our models are not biased against certain communities or underprivileged communities, etc. We have to prove that. How do you prove it? That's such an interesting conundrum. Think about it. Machine learning by itself increases bias. That's the whole point. It's not a rule, it's a bias. So you are putting, but you have to make sure that bias doesn't alienate any specific community. Which means every time you train the model, guess what? It could become different. So you have to create and reproduce it. Hey, based on the data I had yesterday, my model was trained differently. So we have to reproduce that model. We have to go back. As a legal requirement, we have to do that as well. And here is another thing interesting as well. The longer the data you have, the better the prediction is, because in machine learning, the more data, the more the prediction. However, the longer the data horizon you have, the more the cost. And the more data keep on coming, that cost simply escalates high up. And when you do the ROI on that data, it's very difficult to prove that, why it is so expensive and why it's important to keep it. So what we did, and that's the question you all have to ask. So we are going to just talk about a few of the things the solution. Number one is that, remember that all that source systems, multiple technologies, if we had to build a bridge to every technology, we will not get anywhere. Simply because it's impossible to find somebody practically to get something. You have to also understand the SME of those people as well, of the systems they have developed earlier. So what they do. So what people are trying to do here is streaming. So every data comes to you as streaming. That means the SMEs of the systems, the technologies, it doesn't matter what the technology it is, what the SME is that, you stream everything. If it goes to a streaming mechanism, to a pub subsystem or a stream, then anybody can select from it or read from it. Either you persist it, or you decide to stream it and just read it and discard it. Whatever it is, it comes streaming. That's a paradigm shift we're seeing right now for quite some time. So that's a really interesting part. By doing so, we eliminate that source being a separate technology, and we don't know exactly who is doing what, the systems. We eliminate all that. Next is that, consider this one, all data streaming. Oh, what's going on here? Number one thing is that this is where we have we have this debate, data lake or data warehouse. And if so, how many? One data warehouse to rule them all, or have multiple data warehouse, we have multiple technologies, etc. So we decided, long time on, is that it's impossible to find out 10 years down the line what technology will be the prevalent. It's impossible to do that. Today, in Databricks conference, you learned a few of the things actually introduced. These things didn't even exist a year ago. Think about that. Technology changes rapidly. So we can't simply marry ourselves to a specific technology. So data mesh is the only way to do it. So create a fit-for-purpose store as you keep on doing it. And for some things, you have a data lake, a lake for a long-term storage. Sometimes you get that for a analytical store and in a data warehouse, etc. And data warehouse, also you want to have update capability, etc. For the lake, you don't need that because you say you become immutable, you keep on appending it. And because the cost is low, you can keep on doing it. But that becomes a challenge. I have data in warehouse, data in lake. I want data from both. So in the past, the trend was, let's move the data from the lake into the warehouse. And then that becomes consumable. Until that is done, you can't consume it. Another ETL job. Remember that? Nobody wants to wait for the ETL to complete. That becomes a challenge. Likewise, I got something in warehouse. I want to move into lake for long-term storage. Well, until that is moved, or once that is moved, you can't access it here. Now you can only access it over there. That becomes a challenge. I have to write applications that connect to both of them. To solve that, what I see here is this thing called a lake house. So it has the benefit of both. It is a data lake, but it also has the ability to do asset transactions and create all the bells and whistles of it on the top of it. But the key difference is, which is an important difference, the lake house is open format. Every data warehouse I know of, they have proprietary format. In fact, that's exactly how they become performant and thing. So what if you go to vendor X and have that thing, you are logged into vendor X. If you decide to change it in the future to something else, good luck. Extract everything over to some CSV file or something and load it. That becomes a huge challenge. In an open format, you are not logged into a specific vendor. You can get it, and in an open format, you also have lots of vendors who create these libraries or other stuff around it. You can take advantage of that one as well. So Lakehouse is the one. But another thing also we saw in Lakehouse is a trend, which is a great trend, is caching. And I cannot underscore the importance of caching in Lakehouse. By doing so, you actually enable the data access significantly faster. That's the key word here. So the performance becomes either better than the data warehouse itself, or at least the same as that warehouse itself. By doing so, you don't actually have to create in two different environments. And that's something we are also going towards as well, data warehouse. Next is that, this is another safe thing. All of you talk about ELT and ETL. You might have heard that term. And there's a debate going on. And the T stands for transformation. So first, ETL, extract, transform, and load into something. ELT, extract, load into something, and then transform. Where do you do it? And who does the transformation? In the past, it was consumer-driven. A data consumer would go in and do the transformation to suit their own needs. We see a trend to go towards the left of it. In that case, you simply move the transformation as close to the producer of the data. And that's supremely important. I told you, when you stream something, let the producer stream exactly the way you want it. And the consumer isn't allowed to change it. Okay, what happens if a consumer wants something different? Then we ask the producer to put the transformation in the source itself. That's a very powerful paradigm if you think about it. If you do it, it becomes very easy to scale forward. And then what we did, we created data products and data versioning as well. By using the versioning, we could figure out reproduce the models we have done before. So data product concept means that a data producer creates something in a specific manner without a change required by the consumer, and consumer simply takes it. And without knowing anything about it, it's like a toothpaste. Do you know how the toothpaste is made? You don't. You don't have to. That's the whole point. You go and buy the toothpaste. It works exactly how it's supposed to. Likewise, why can't you create a data product, like a checking account or a savings account, and that's just there? you can simply go and grab it and do it. If you want a different flavor of the toothpaste, you don't change it. You ask the Colgate-Palmolive or whoever they produce it to change it there, and then you get it. Same thing data products as well. That concept we see as well. And putting it all together very, very quickly is that we see everything is streaming. Everybody does the streaming in a data product, which is already established and cataloged and well-documented and everything else. We create versioning. So every time you train the model, we keep a feature of that, which we used as once, and keep it aside. For in the future, if you have to reproduce it, we can do it. And then we have Lakehouse, where you can store both. Long-term, you can also create caching, etc., to make the access very fast. So altogether, it makes the data products really, data environment really useful for our end users. That being said, we are hiring. So if you are interested, absolutely come on and join us if you want to join me. Thank you very much.
To close out our customer keynotes, here are our final two speakers from Point72 Asset Management, Christopher Daringen and Shraddha Shah, to tell us about their data journey with Databricks.
Almost to the finish line, guys. Hang in there. Anyway, thank you for the introduction, Marcello. Appreciate it. Very excited to be here today as a part of the Databricks community to learn from you guys, of course, but also share our experience with building data infrastructure for Point72 and our market intelligence business. I'm also very excited to be joined here today with my esteemed colleague and our Spark expert, Shraddha Shah.
Thanks, Chris. Hi, everyone. Thanks for sticking around. So our data journey started nearly 8 years ago. And there's been a number of successes and challenges along the way. Though one thing we have come to realize is the importance of finding vendors who are willing to partner with you. And Databricks has been along for the ride during nearly all of it.
Absolutely, yeah. A good partner in this space is going to have technical leadership in artificial intelligence, cloud computing. They're going to be staying very close to open standards. And they're also going to set up user communities like this one. And they're also going to listen to customers, and they're going to incorporate feedback into their product roadmap. Point72 doesn't normally speak at events like this, but because of our really strong partnership with Databricks, we feel really privileged to be here today to share our experience. And I hope those of you in the audience also find something beneficial in our data journey story. So, we're going to spend a few minutes today. We'll talk a little bit about market intelligence, tell you what that's all about, what we do, and how our technology team supports that. We're also going to spend a little bit of time talking about our what we call technology principles. These are important things to Shraddha and I that influence our technology decision making. Then we'll look at how our infrastructure has evolved over the years since we really got started in 2015. As we've applied these principles, you can see a steady evolution of our stack over 2-year increments. We'll take a close look at that. Then Shraddha is going to talk a little bit about some of the current day challenges and future opportunities that we feel the Lakehouse architecture has a lot of potential helping us solve. So 15 minutes. I don't think we have a lot of time, so let's dive in and get started. So, Point72, I don't know if a lot of you guys know Point72, but we're in the baseball business.
And have a side hedge fund business.
A little hedge fund on the side. So one of the main lines of business at Point72 is something called long-short investing. And the way long-short investing works in short summary is you have teams of portfolio managers and analysts studying companies in a particular sector, like healthcare, industrials, and energy. And what they're trying to do is build models that show how these companies are actually performing. And if you're really good at this modeling exercise, you can spot companies that are undervalued or overvalued relative to the market. There's obviously a lot of money to be made there. But we're in an environment where we have very aggressive competitors who are armed with technology and data. So to do well in this space, not just to do well, but really to survive in this space, you need what's called proprietary research, which is delivered by our market intelligence organization. Proprietary research gives you, insights into how companies are performing, things that you just can't readily get anywhere else. And our analysts can plug that into their models and ultimately make them better. And it's the role of our team to kind of build proprietary research and get it out the door. So how do you build a proprietary research business? There are a couple key components to this. First of all, you need a data sourcing function. You need people going around looking for data in non-obvious places. Sometimes it's public, sometimes it needs to be purchased. This data sourcing function has to work very closely with a compliance organization, right? You need to make sure that as you bring and source these data sets, it's done in a compliant fashion. You need a core competency in data engineering, right? So a lot of these data vendors have varying degrees of technical ability. You know, they're producing data in all sorts of crazy formats and mechanisms. You bring the data in-house, it needs to be cleaned, it needs to be brought into a format that people can actually use. So that's really kind of the key responsibilities of our data engineering team. You also need a data science team, right? Our data science team can normalize data, they can remove biases from the data. Ultimately, they're building trends and signals on this data that show us something interesting that's going on. Finally, for proprietary research, you need a product team. These are the people that bridge the gap between the questions that our portfolio managers and analysts are asking about the real world and what we're seeing in the data. And they help us design products that allow people to engage with data and not just get an answer, but maybe explore, dig in a little deeper, and find additional insights. So the table's set, right? You've just bought a whole bunch of really expensive data sets. You've got these highly talented data engineers, data scientists, product people all around the table. But if you don't have technology infrastructure that allows you to collaborate with data, to quickly do data evaluations, to quickly build models, test them out, put them in production, if that infrastructure is not there, you're going to be dead in the water. So really, the role of our team is to make sure that that infrastructure is in place and working properly. So I don't know, Shraddha, one of the interesting things about my job, now we have all this really cool data sitting around, people tend to call up and they ask questions like, what do you see in the data? Like, does the data answer this question? You know, what is the data telling you? And it's kind of neat, it's kind of fun.
Absolutely, that's what sold me on the job. You have an example?
Sure, let's take a quick look at an example. A couple years ago, got a phone call from an analyst, says, I need to know everything you know about all day breakfast, and hangs up the phone. It's like, what's going on? Like, so this kicks off a fire drill in market intelligence. You know, a number of people get involved, and we end up doing very deep research across a wide range of data sets. The question is, to the business, is like this nameless breakfast company, fast food company launched all day breakfast, and we want to know, is it actually working, right? Are people buying all day breakfast? Do they keep coming back? Like, is this actually benefiting the business? So one of the things that we did a couple things across a number of data sets. But one of the data sets we looked at is a foot traffic data set that actually gives us insights into people coming and going from different retail establishments. And we're able to see, in the case of this particular chain, foot traffic at their store locations. So what this shows you is, you know, time is on the x-axis, so time is progressing left to right. And then on the y-axis, you have time of day. So you see these bands. The bands represent foot traffic, right? So you can see this kind of relatively strong middle band. That's the lunch crowd, right? The top band on the you know, around 9 o'clock, that's the breakfast crowd. And there's kind of this dinner crowd towards the bottom. So leading up to event A, which is the launch of all-day breakfast, right? This particular chain had, you know, a pretty decent lunch crowd, a so-so breakfast crowd, and a pretty anemic dinner crowd. But sure enough, all-day breakfast gets launched, and all these people come out of the woodwork, right? And they're just eating tons of all-day breakfast. Like, you see that really dark band there, right? Everyone's going for bacon and eggs in the middle of the day, coming back at night and get more bacon and eggs. It's crazy. And like, you can actually see this unfolding in the data real time in a quantitative sort of way.
What's going on around your end? Traffic's falling off.
Sure, right? So this was kind of fun, and we kept watching it. And like, sure enough, January 1st, like, whew, everybody disappears. Like, what just happened there, right? I don't know if you're like me, but like January 1st, like, you know, maybe set some New Year's resolutions. Maybe you've been eating bacon and eggs for 3 meals a day for the last couple of months. You know, maybe let's cut back on that a little bit. And sure enough, like, all these all-you-can-eat all-day breakfast people just disappeared.
Healthy resolutions, definitely me. Something's going on around going into spring, though. Uptick in traffic.
Sure. So again, if you're like me and you make New Year's resolutions at the beginning of the year, you tend to break them around April, May, June. And what we also saw are all these customers who were binging on all you can eat breakfast, all day breakfast, were starting to come back at this time frame. And that crowd came back. People just couldn't get enough. And sure enough, the business picked up again. So I don't know, all this talk of all day breakfast, Shraddha, it's making me kind of hungry. Maybe we should go grab some pancakes after.
I'm already hungry.
All right, excellent. So let's get back to our data journey. As I mentioned, we're responsible for the technology infrastructure, and we try to set some principles that guide our decision-making around our infrastructure. One of our most important principles is anything is possible, should always be your mantra. So if you're in a position where you're supporting a business with technology, you never want to find yourself in a situation where you say, I can't do something because there's not enough storage, or I can't do something because I don't have enough compute capacity, or I don't have the latest libraries, or I don't support that framework, right? These are things that we used to say in the early days of market intelligence because we had limited infrastructure. And it was like, for me, it was nails on a chalkboard. I felt terrible having to say these things. But luckily with managed services today and vendors like Databricks, you shouldn't have to say those things to your partner. It should really just be a question of cost. Does the business case that you're proposing here justify setting this up and doing this particular experiment? Number two, having all your data in a single location makes life dramatically easier. Probably the best example of this I saw was my first week on the job, and I met an analyst on one of these PM teams, and I said, walk me through your day. Like, what do you do? He looked disheveled, rings under his eyes. He's like, well, I get up at like 4 o'clock in the morning, and then I have to call these APIs, and I can pull this data down here, and I go to this FTP site, and I collect all these Excel files, and then I run a Python process over here, and then there are these 3 databases, and then by the time 5 o'clock in the afternoon rolls around, I can actually do some real work, right? I can actually do some analysis. And he said he was spending 20% of his job actually doing real work, and 80% just getting data where it needed to be and in the format he needed. So it was clear that if you don't have a central data environment and tools to access data centrally, people waste a lot of time pushing data around. And it really should be a principle of ours, all of ours, to let people focus more on business problems and less on moving data around. Third, data storage must stand the test of time. So if there's one thing I think you need to get right in your data architecture, it's thinking about how you are going to store your data. On our team, we've spent a lot of time thinking about S3 as an object store, how to organize that data there, knowing that we're going to have tons and tons of data. Once people come on board, they're going to build reports. They're going to create production jobs, and then those production jobs are going to create more data, and other people are going to come along and create reports. And these dependencies form hard contracts that are extremely hard to move once they're in place. So if there's one thing to spend time on up front, it's to get this data storage put in place and working properly. Again, we use S3. We spent a lot of time, Shraddha, I know these meetings were quite boring, but talking about S3 storage standards. We use snappy compressed Parquet files at the moment as kind of our file format standard, although I'm very excited about this morning's talks. And we're probably going to take a closer look at Delta as a standard going forward. Next, compute and analysis must be able to evolve rapidly. So while you want your data to kind of stand the test of time, the world of compute is just evolving rapidly around us, and we need to be able to keep up with that. I don't know about you, but if you're familiar with AWS, there's a guy, Jeff Barr. He announced his new EC2 instance types, right? Very exciting. It's like, oh, this is great stuff. New processors, more cores, more memory, better storage. Like, I want that. I want that right now. And like, I get really excited. And so it's not just with hardware. You want to adopt new hardware as quickly as possible, but you want the latest libraries, the latest frameworks, the latest tools, right? So as you think about your stack, make sure that it allows you to kind of pull all the latest and greatest in terms of compute in immediately. You're not held back by old versions and old technology. Next, engineers and data scientists should be focused primarily on analysis. In the early days of market intelligence, we were spending time setting up operating systems. We were dealing with hard disk failures, network stuff. This is fun stuff, don't get me wrong. Like, I enjoy it as a kind of geek out on this stuff, but it's not where our business wants us spending our time and money. With managed services, you can move up the value chain closer to the business problems. And my experience has been when people are working most closely to the business problems, they're actually happier and they're enjoying their jobs more and it's what the company wants us to do. Finally, as a principle, actively manage your tech debt and proactively migrate to the latest tools and libraries. So in market intelligence, we make a concerted effort to burn down and rebuild big parts of our infrastructure every 2 years, and we'll take a closer look at that in the next stack. It's a daunting proposition because it's disruptive. It takes a big effort. And some people say, why are you doing this? But I can assure you the benefits of doing this outweigh the disadvantages. First of all, if you build something with a 2-year horizon, you're not paralyzed by perfection, right? This thing just can get done faster. You're able to be more flexible, more dynamic. Second of all, by rebuilding things on a regular basis, you don't have all this legacy infrastructure holding you back, right? So all that maintenance and support costs and having to train people on legacy systems and these complex architectures, you're not held back by that. And that is really a big tailwind when it comes to productivity. So let's take a quick look at kind of the evolution of our architecture as we apply these principles. And we'll just highlight a few things throughout the timeline, and then we'll hand it over to Shraddha, and she'll talk about the future. So prior to our arrival in 2015, things were not going very well, right? We had just purchased our first alternative data set, which interestingly arrived in the office of our compliance department in a box of CDs. Not DVDs, CDs. There's a lot of CDs, right? And early attempts by the firm to use vertically scaled on-premise systems to work with this data had not gone well. Like, things were not getting done. It was kind of a flop. So immediately knew, look, we need to be fast here. We need to move, we need to be flexible, we need to be fast, and we need a distributed framework to actually work with this data. In 2015, we built our first Hadoop cluster in AWS with a meager 45 terabytes of data. But we were able to get our first production pipelines up and running. And most of the jobs, as you remember, Shraddha, were MapReduce, Hive. But we started experimenting with Spark. And we're like, this is kind of neat, much better than MapReduce. And we actually met Databricks. Does anyone remember the Strata conference? Am I dating myself? But there used to be a big data conference, Hadoop. Yeah, OK, anyway. So I met someone at Databricks there. We hit it off, and that started our relationship. 2017, our business really started to take off. Now we have dozens of production data pipelines. And now people rely on our data before market open. So it's not like, if the job dies, you just restart it, no big deal. You have to make sure this stuff runs. So SLAs are now important. We burned our cluster down to the ground and built a new one in 2017, this time with 1.4 petabytes of storage. Thought, all right, that should have us covered, right? It's a lot of storage. In 3 months, it was already full and maxed out, and we had to turn away business because it wasn't adequate to do the job. So we were already, within 3 months, had outgrown something we had just rebuilt. We continued to work with Databricks, and we actually did an on-premise POC with them that was such a success. We said, you know what, this is the future, right? Elastic compute. This is what we want to do. We said we need to get away from static computing infrastructure. And in 2017, we said we're going to make a commitment to get on Databricks. 2019, again, just to accommodate our growing business, which now has over 100 production pipelines, multiple SLAs, and now we're dealing with users not just in our market intelligence business unit, but in other parts of the firm. Our business is really taking off. Once again, we shut down our old Hadoop cluster and built a third Hadoop cluster, this time with 4,000 cores, 15 terabytes of memory. And it also became maxed out within a few short months. So interestingly, so this is, 2019. We're also looking a lot at storage standards in S3. As I mentioned before, we spent a lot of time thinking very carefully about, as we knew we were going to get off HDFS, we were going to decommission these Hadoop clusters. Everything was going to live on S3. We spent a lot of time working on how that was going to be organized in these meetings that I discussed. So in 2021, we actually shut down our Hadoop cluster permanently. And it was actually a lot of fun. Cassidy's in the audience, actually led a decommissioning ceremony. It was kind of like a New Orleans funeral for our cluster. We pulled up all 4,000 cores of processing in the EC2 console, and Cassidy, with a lot of fanfare, hit terminate on all of them, and they all shut down. And the legend has it that the lights in Virginia burned a little brighter that day. And we were happy to see it go because, look, anytime you can decommission a big thing like that, it simplifies your architecture. Again, you want to keep maintenance and support costs down through a simple architecture. So we're fully bought into Databricks at this point, and now our focus is shifting to other things, more interesting things, right? As I mentioned, we have more users, other business units at the firm. And with E2, which is the new version, was the new version of Databricks at the time, we're able to spin up new workspaces for these teams and allow them to operate independently in a very flexible sort of way. I think another big kind of thing that we focused on in 2021 was users who are interested in interactive SQL. So we love Databricks, right? So we're mostly PySpark users, but there are a lot of people out there that just, look, I really want to work with the data in SQL. And we were kind of dismissive of that, just use Spark SQL, but they really loved, it was called SQL Analytics at the time. And we worked very closely with Databricks on early versions of that product, piloted it, rolled it out, and it was a huge success. A lot of people liked it because it worked at the speed of thought and they were able to do their analysis in real time. So as we move to 2023, just two themes that I'll highlight, and I'll hand it over to Shraddha. Number one, we're working with our partners in our central IT function now to make this data lake, not just a data lake for alternative data, but a data lake for all the data sets at the firm, small and big. I think that's kind of a big focus. And the other focus right now is we still have a fairly large on-premise SQL Server data warehouse, and we're actively trying to move that into the cloud. And we certainly think Databricks can help us there. So just before I move on to this slide, I'll highlight, I think this is a good story for a couple of reasons. It's demonstrating a huge growth of the business, but I also think about our team, right? Our engineering team has only grown incrementally over time. So I think that's a sign that you're making good decisions. Our technology costs are also still a small fraction of our data costs, which I also think is a good sign.
Cool. Thanks again for sticking around. Just a few more minutes before we all get to enjoy the pancake dinner promised earlier. And also, we don't have a job slide, but we can consider the next slide for the exciting stuff we are doing. All right, back to the business. As Chris mentioned, now Databricks is being offered to everyone at Point72 for any kind of data. And thanks to the ever-changing environment, economic environment today, more and more users within Point72 wants to work with data, be it traditional data or the less traditional data like alternative data, which is bread and butter for us. And that's why it's very important for us to now align data, people, and processes within the firm. So let's take a look at some of the key challenges of our platform today. First one is cataloging. Not the first time you're hearing today, but with the growing user base, we get hammered with questions like, what data do you have? And as simple as it sounds, this remains an underinvested area of our data ecosystem today, where we need to ensure that our data assets are not only consistently documented, but also discoverable by our users easily. The next one revolves around data sharing again. Not the first time you're hearing it. But data sharing for us is a little unique in our setup because data sharing, imagine it in a setup where you have multiple Databricks workspaces. So S3 being a central data repository, sharing data is pretty straightforward. However, imagine a setup where you have 20 different Databricks workspaces just because a long, short teams that Chris mentioned earlier, power users, as we call them, they want to protect their intellectual property. Also, cost, transparency, and compliance and regional restrictions play a role here. Just imagine sharing tables without recreating the schema on 20 different multiple Databricks workspaces is definitely a challenge today. And I hear a couple of people talking about Unity Catalog, whispering about it. We are evaluating Unity Catalog as we speak, along with AWS Glue today as a potential solution to this, to just simplify our onboarding challenges. And the last one is my favorite one, usage intelligence. So our customer base comes with varying levels of technical sophistication today. And that's why we often find ourselves, I have my colleagues in the audience as well, just answering questions around, hey, can you optimize my job? Like, can this query be further optimized? Imagine in a situation where you have multiple Databricks workspaces, how do you even keep track of what users are doing in their own environment? How to proactively flag inefficiencies. Like the other day, we noticed one of our users had relatively large cluster up and running 24/7 for what looked like a couple of queries a day. We do have internal setup and internal tools to help with us, which is very similar to Databricks Overwatch project. We just wonder, why not make it part of the Databricks product right out of the gate, right?
Yeah, Junta, come on. Make it happen, come on.
All right, enough about challenges. So it's very important for us that we keep an eye out for exciting opportunities that expansion can bring as well. Specifically in an environment where things are changing constantly, and like JP Morgan mentioned as well, where like everyone is now after deeper and faster insights, right? And we have this amazing data assets in-house. We can certainly do a lot more with them just to unpack the full potential of the data assets we have. Sorry. Let's start with machine learning. So there's a lot of room for us to grow in this space, specifically to move up the maturity curve that everyone keeps talking about. And right now in the volatile market that we are, our users, they want to run quick experiments and want to test various strategies. Like year over year doesn't cut it anymore. I want to run more and more strategy, retrain my models. What do I do with COVID quarter, right? Excluded from my analysis. How does that impact my model? How does that impact the performance and the result of my models? I want to make quick adjustments to my panels. So if we had a mature MLOps system that not only allows for rapid development and deployment of models, but also helps monitor for errors, specifically to avoid any unexpected behavior in production. And finally, streaming. Streaming is an untapped opportunity for us today. Given how fast data is changing, how do we help our users be on top of what's happening in the moment? Like the other day, someone asked us, can I track real-time updates in natural gas ecosystem? With so much going around, like gas prices and the supply chain logistics, historically, our answer to this has been running our batch processing more frequently. So that's near real time. However, with Lakehouse, we may be able to reduce the barrier of entry to adopt some of this streaming use cases more and more, and then help our infrastructure work at the speed of thought.
Excellent. I'm excited. And I think we're going to need to hire some engineers to get all this work done. Excellent. So I realize we're running a little over, so just some closing thoughts. Look, the data journey never ends, right? You have a lot of challenges ahead of you. The world is changing rapidly around us. You have a lot of difficult technology decisions to make. Good luck. But as with difficult decisions in life, it's always good to start out with principles, right? What are your technology principles? So that, I really encourage you guys to think about what your own principles are and help that be a guiding light as you make your decisions. Second, brace for success, right? What you're about to build or in the process of building will be used by more people and in more ways than you ever imagined, right? Now is the time to think about how to brace for that success, and there's some points on how to do that. Finally, listen, as you think about your data journey, you want to think very carefully about your technology vendors. Who do you want to bring along the ride for you? For us here at Point72 and Market Intelligence, I think Databricks has really been a terrific partner on our data journey. So thank you very much for your time, for listening. Really appreciate it. Thank you.